We have studied economic load dispatch between different units within a power plant in the previous lecture. So now we have to do some problems based on that. So moving on to the first question. The cost characteristics of two units in a power plant are C1 is equal to 0.4 P1 square plus 160 P1 plus K1 rupees per hour. C2 is equal to 0.45 P2 square plus 120 P2 plus K2 rupees per hour, where P1 and P2 are the power output in megawatt. Find the optimum load allocation between the two units when the total load is 162.5 megawatt. So, ഒരു പവർ പ്ലാന്റിൽ രണ്ട് യൂണിറ്റ്സ് ഉണ്ട്, രണ്ട് ജനറേറ്റേഴ്സ് ഉണ്ട്, രണ്ടിൻ്റെയും ഫ്യൂവൽ കോസ്റ്റ് തന്നിട്ടുണ്ട് C1, C2. ഇനി നമുക്ക് കണ്ടുപിടിക്കേണ്ടത് ഫൈൻഡ് ദ ഒപ്റ്റിമം ലോഡ് അലോക്കേഷൻ ബിറ്റ്വീൻ ദ ടു യൂണിറ്റ്സ് വെൻ ദ ടോട്ടൽ ലോഡ് ഈസ് 162.5 മെഗാവാട്ട്. 162.5 മെഗാവാട്ട് ലോഡ് ആ പ്ലാന്റിൽ വന്നാൽ എക്കണോമിക്കലായിട്ട് നമ്മൾ ഈ ലോഡിനെ ഈ രണ്ട് ജനറേറ്റേഴ്സിനും എങ്ങനെ ഡിവൈഡ് ചെയ്ത് കൊടുക്കണം എന്ന് കണ്ടുപിടിക്കണം. That is, we have to calculate the value of P1 and P2 in order to supply a total load of 162.5 megawatt such that the total load is minimum. So now let us solve the problem. So for economic load dispatch between units within a power plant, we have already derived an equation known as equal incremental cost rule. So we have derived that in our previous lecture. So in that method, we got the condition for economic load dispatch as equal incremental cost. So the derivation or the equal incremental cost rule says that for the fuel cost to be minimum, the incremental cost of all the units should be equal. So we have got the condition as dCi divided by dPi is equal to lambda. For all the units, I is equal to 1, 2, 3, etc. n. So dCi by dPi is the incremental fuel cost for the unit I. So the incremental cost of all the units should be equal, and we have got another equation in that derivation, that is the total load demand PD should be equal to summation I is equal to 1 to n Pi, that is total load demand is equal to sum of generation of all the units, that is P1 plus P2 plus etc. Pn. So this equation is known as power balance equation. So we already have these two equations. For economic load dispatch, incremental cost of all the units should be same and it is equal to lambda. Also, the sum of power generation of all the units is equal to total load demand PD. So by using these two equations, we can simply solve this problem. So here we have two units, unit 1 and unit 2. So take the incremental fuel cost of both the units. So first dC1 divided by dP1 is equal to, so C1 is here, we have to differentiate C1 with respect to P1. So 0.4 P1 square, derivative becomes 2 into 0.4 into P1, that is 0.8 P1 plus 160 P1, derivative becomes 160, K1 is a constant, so derivative is 0. So similarly, dC2 divided by dP2 is equal to, C2 is here, derivative becomes 2 into 0.45 into P2, that is 0.9 P2 plus 120. So these are the incremental fuel cost of both the units. Now we have to equate the incremental cost of each unit to lambda. So here this term is equal to lambda and also this term is equal to lambda. So now From this equation, write the equation for P1 in terms of lambda. That is, from here we can write P1 is equal to lambda minus 160 divided by 0.8. Lambda minus 160 divided by 0.8. Similarly, from this equation, write the equation for P2. P2 is equal to lambda minus 120 divided by 0.9. So we have got expressions for P1 and P2. Now we have to use the power balance equation. So according to power balance equation, sum of generations is equal to total load demand. So here we have two units, so two generations P1 and P2. So P1 plus P2 should be equal to total load demand PD. So we have P1 as lambda minus 160 divided by 0.8 and P2 as lambda minus 120 divided by 0.9, which is equal to total load demand PD. So our total load demand here is 162.5 megawatt. So now simplify this equation and find out the value of lambda. So solve it in the same way that I am doing. So it will be the simplest way. So this term can be written as lambda divided by 0.8 minus 160 divided by 0.8 plus lambda divided by 0.9 minus 120 divided by 0.9, which is equal to 162.5. So now take lambda common. So lambda into 1 divided by 0.8 plus lambda divided by 0.9. So 1 divided by 0.9. And take all the constant terms towards the right side. So right hand side becomes 162.5 plus 160 divided by 0.8 plus 120 divided by 0.9. So now solve this term 1 divided by 0.8 plus 1 divided by 0.9. LCM ഒന്നും എടുക്കാൻ നിൽക്കണ്ട, ഡയറക്റ്റ് ഈ ടേം കാൽക്കുലേറ്ററിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ മതി. So when you add up these two terms, it will be 2.3611 lambda. 2.3611 into lambda, and the right hand side becomes 495.833. So from this calculate the value of lambda. So lambda is equal to 495.833 divided by 2.3611, which is equal to 210. The unit of lambda is rupees per megawatt hour. Lambda is equal to incremental cost, right? dCi by dPi is equal to lambda. The unit of incremental cost is rupees per megawatt hour. So we will get the value of lambda as 210 rupees per megawatt hour. Our aim is to calculate the generation of each unit, that is P1 and P2. So we have already written the equation for P1 and P2 in terms of lambda. So from that equation, calculate the value of P1 and P2. So we have P1 is equal to lambda minus 160 divided by 0.8. Lambda minus 160 divided by 0.8, which is equal to 210 minus 160 divided by 0.8. So when you calculate this, you will get the value as 62.5, and the unit of P1 is megawatt. So now calculate the value of P2, and we have P2 as lambda minus 120 divided by 0.9. So lambda minus 120 divided by 0.9, which is equal to 210 minus 120 divided by 0.9, and it is equal to 100 megawatt. So this is the answer. So we have got the generation of unit 1 and unit 2 such that total fuel cost is minimum.